I am super excited to present a journey through integration testing with Go. And of course, some of the learnings and challenges along the way. So I'm Samantha Coyle, and I do work at Intel. So I'm obligated to share a few notices on security and ethics that we try to abide by. All right, so we'll be covering a few different pieces for this presentation. We'll start with an intro, and from there, we'll cover the three main components of our integration testing solution. So we'll start with test dependencies, go on to the test cases, and from there, wrap it up with the test report, all while interleaving those challenges and learnings along the way. And we'll wrap it up with the conclusion after that. So I do go by Sam, and I am in the Internet of Things group at Intel. We work on a lot of different Go microservices for computer vision-based applications for retail or healthcare and so forth. This project and journey involves the Guardians team, and you'll see Anthony here. He's a bit bigger than everyone else, and that's to help highlight that he was one of my main supporters, and he gave me a lot of good feedback throughout this journey. So definitely wanted to highlight that. All right, so let's get into some of the background context. Well, we all know the software development lifecycle, SDLC, right? We go through this process of gathering those requirements, building out the architectural components, actually implementing things. I like to call this the fun part. I think we can all agree. Hopefully throwing some unit tests into the mix. And then that's a smooth transition into that test phase, right? And you test things based on what makes sense for your use case. And then you end it with maintenance. So naturally, I'll be talking about a journey through integration testing. So we'll focus on that test phase of SDLC, right? So we've gone through some of this process, and we're ready to focus on that testing piece and get that confidence that our solution works as we expect. With integration testing in particular, I've seen a few different definitions, right? So we've seen it defined as maybe the testing of two services, maybe an internal component like one of our awesome Go microservices with an external component like a live database. I've also seen it defined as the integration of your solution and testing all of those components, right? So we'll be focusing on that version. Now that we're all on the same page as to what we're talking about here, I'm going to ask y'all some questions, right? Keep y'all engaged. So raise your hand if you've worked on your team's integration testing solution before. Wow, quite a few hands. How about if you've worked on any testing for your team solution? I feel like I should see more hands raised. We all work on building tests for our code because we want to be proud and validate that it works, right? And so with integration testing in particular, there are a few considerations we need to be mindful of. The first of which is making maintainable code, right, for our integration tests. Go is idiomatic by nature, right? And so with as much thought and consideration that we give to our Go backend logic, we need to give that same effort towards our integration tests. So you need this cohesive way with minimal upkeep and minimal drift potential to actually test what you're deploying. Next up is speed. So with integration tests, you're spinning up a bunch of Docker resources, right? The spinning up of everything, then running those test cases, and then that cleanup phase takes time. So you need to be mindful of how long it takes. From there, we're at GopherCon, so we'll be talking about some Go packages naturally. And we'll wrap it up, right, and talk about those release requirements that our team had for our integration testing journey, which is two pieces, right? Integration tests, and then our test report. So the use case we'll be covering here is a smart city. And our team wanted to focus on that situational awareness to improve city safety. Our solution was based on and inspired by a proprietary solution But we ended up pulling a bunch of open source tools together to build ours. And you can see there's kind of a lot going on. And so, we had to look at what are our smart city solution integration testing needs. So we needed a way of working with this busy architecture, right? There's a lot going on, lots of open source tools, and also in yellow, 3 Go microservices. One for camera configuration management, one for videos, right, to host those playlist endpoints, and another for our inference service for searchability. We also needed a way of working with video data for our integration tests, right? Because we're not working with live cameras here for our integration tests. So for that, you'll see in step 1 here on the diagram, we worked with an RTSP simple server to allow our team a way of quickly setting up and simulating an RTSP server with that video data to test with. RTSP is an acronym. It stands for Real-Time Streaming Protocol, and it's a transport. So you can think of it much like you have HTTP and TCP as common transports for the web. So from here, we had our video data to test. And then we needed to think about, okay, we need scalable and maintainable code for our integration testing needs. And so we went from there. Our org historically used a Python robot approach and framework for our integration tests. And so, as Go developers, and a lot of Go developers in our org who have practiced with some of the Go best practices, as well as giving each other constructive feedback on Go code, I said, well, why don't we try a Go solution for integration testing, right? We're already leveraging that native Go test framework for our unit tests. So let's expand it. No brainer, right? So we took a risk, and there began our journey. Our integration tests had 2 main things that we needed, right? We needed those integration tests, right? That's obvious. But we also needed that test report for a release requirement for our integration testing solution. So you can see there's 3 things going on here. For our integration tests, when you hear that word, right, or 2 words, always think 2 things. First, spinning up of those test dependencies. And second, the teardown the test cases from there. So again, 2 pieces of your integration tests. So for spinning up our test dependencies, we use something called TestContainers-go. It's a Go package. And from there, we had our test cases, which we defined a custom package for. So 2 responsibilities, 2 packages. From there, we had our test report, which we use the Go test report package for. So I'll cover all of those. So for our integration tests, we have to start with the first piece, right? And so we'll deep dive into our test dependencies. So for our test dependencies, we ended up using this package called TestContainers-go. So this is the backbone of our integration testing solution. It's a package that's a wrapper around the Docker daemon that's designed for testing. So anything you can run with Docker, you can spin up with TestContainers-go as a way of better integrating with your tests. And you can see there's a lot of good going on here, right? It's also really great because TestContainers-go is part of a more global test containers community. And so TestContainers-go is actually inspired by the Java version of test containers, which is really awesome. And beyond having some good documentation that you can find here, they do have a few key features as to why we chose this package over some of the alternatives. The first of which is garbage collection. So TestContainers-go spins up this Ryuk Reaper container alongside your services so that you don't have to worry about orphaned resources, right? So when it comes to integration testing, if you have something that has an issue, like a test case that fails and services are left hanging out, well, that Ryuk Reaper will clean it up for you after 10 seconds after that test completed if it sees something hanging out. So you don't have to worry about that. TestContainers-go enables you to build to test what you're deploying. So you can build based on a Docker file or even a Docker Compose file, which was important because our smart city solution leveraged a Docker Compose file to orchestrate our solution. So we were able to use that same Docker Compose to spin up our services to work with our solution, but also for our testing, for our integration tests. From there, they also enable you to capture the logs, right? So you can define these log consumers, which capture what's being written to standard out and error during your test cases. Pretty useful, right? Follow along during your tests. And you can also send different commands and different configuration files to your containers if you have certain configuration needs for your integration tests. So lastly, I know there have been a lot of changes in the Docker community. TestContainers-go supports the use of Podman instead of Docker if you do want an alternative. So I want to pause here because I'm not here to sell any of you on a package. I did want to point out the key features, though, as to why we chose this one over others. So we've chose this package, and now we want to get a sense of how it feels and how it works. So we worked with it for a simple test service. You can see here, we have the container request, right? It's pretty easy to read, idiomatic, and really easy to customize. So we're using our Docker file. We have certain specifications and configurations for this container, and we're waiting for a certain log. We're waiting for that RTSP server log to occur before our test continues. Pretty useful for testing, right? And we also have different network and bind mount configurations established. So we define this container request and use it to start that container. Again, really easy to see, and you can start your containers at different points in time. But that's not necessarily useful if you have a big project with a bunch of services, right? So that's not scalable nor maintainable. And so we had this Docker Compose, right? This is a snippet. We had a bunch of other services going on here. But here's that RTSP server. And here's 4 lines of code where we're working with that Docker file and that same service, right? You see that same wait strategy where we're waiting for that log before we continue. And so that's where we kind of came to a lot of the initial learnings for this journey, because we ended up sticking with that Docker Compose approach. And you can see here, there are a lot of things going on in that picture, right? A lot of wait strategies. And it's probably a little overwhelming trying to read all of them. And that's not even all of them. And something else to note here is when you're picking a wait strategy, right? If you want your service to wait for a certain thing, like a specific server log or a health check endpoint or whatever makes sense for your service, you can even use multiple wait strategies. So it makes it that much harder to know which to use when, because you can even implement their interface and create your own. So lots of options. Makes it hard to choose. So for us, we started with that wait for log strategy, which y'all saw on those past slides, because often our servers have logs, right? And from there, we then thought, okay, our smart city needs to wait for our video data to propagate. So we looked at that first strategy, to wait for SQL. We wanted to wait for specific data to propagate into our database. So we looked into the internals of this package, right, of this wait strategy. Now I'm going to ask you all another question. So hopefully no one's sleeping. How many of you have used a select one query in your code before? Show of hands? Okay, a few. Let me end that question with another question. How many have used this select one query in production code? Yeah. Oh, okay. 1 or 2 hands. So the thing here is, right, this is a way that you can get something out there and build with it and then look at, okay, well, what should I actually be looking for? And so I think that's what was going on here. And so this was for TestContainers-go version 0.11.1. And so I couldn't specify the query I wanted, right? That was a magic string we all saw. So I made an issue. So that was a limitation at the time, right? You see there's a few thumbs up, few discussion comments here. And thankfully, thanks to the open source community and how great it always is, it's a closed issue. But unfortunately, it wasn't closed in the time frame that we needed. So we looked at a workaround. And I know this is a bit of code on the slide. There's actually more behind it that you don't see here, supporting this wait for SQL strategy that we created, right? We implemented their interface. And so to kind of look at the big things here, we've defined this wait strategy on Postgres, right? So we've defined our own wait for SQL query strategy with some configuration and a few things blocked out. And you can see here, I'm able to specify the query that I need to make sure that I have what I need, which is that video data for integration testing. So again, not ideal because we had to find a workaround. We have a bit more code beyond what you see here, and it's not as easy as we would like to understand from the get-go. So we looked at, well, there are a lot of other wait strategies. Y'all saw, there's so many. And so we looked at what are the other ones that we could maybe use here. And that brought us to a wait strategy for our reverse proxy, right? For Nginx, which is now an HTTP strategy. So we've shifted away and we're using a different wait strategy here. And you'll see the endpoint there is for video, camera, one playlist, right? So I mentioned we had a video go microservice. And this endpoint here, what it does is it checks our database and gets that video data, right? So we're accomplishing the same goal here to make sure that the specific camera data is there for our integration tests to proceed, but it's a different way of going about it. And thankfully, this is all of the code needed for this wait strategy, right? So less to maintain and manage on our end. Not 100% ideal because we had to define a workaround. So not perfect, but got the job done. Thankfully, in v0.14.0 of TestContainers-go, they do enable a way of using a different way of specifying your query, right? So you're not enforced to use this select one. So I don't think any of you should experience the same issue my team did here, which is good. That brings us to our test cases, right? We've spun up our services. We're ready to go. We're ready to start looking at those test cases for our integration testing journey. Here are a few of the things that we looked at for our smart city solution when it came to what do we need to test for our integration tests. Well, we looked at our services. So we had our camera management, we have our video service, and we have our inference service. These Go microservices interacting with a database, we should test, right? We should check it. We also had a Python media pipeline streaming data. So we needed to check that too. And when it comes to your tests, we should all have negative tests thrown in the mix to make sure we're covering some of our bases. And so we added a test to check for that stopped camera feed, right? In a production environment for a smart city, your camera could drop from that network, right? It could stop streaming. It could get unplugged or whatever, go into maintenance mode. Lots of potentials for it to stop. And so how did our solution work when that happened? And that brought us to some of our slower, natural learnings. These are kind of fun and yeah, they naturally evolved. So you can see here, we have table-driven tests. We all know and love it. And you can see it's a little bulky. This is just 3 test cases. We have a scope defined here with what service we're looking at, testing. We have the name and a few different fields from there. Again, a little bulky, and it kind of got repetitive quickly, right? Copy, paste, copy, paste. And so it kept increasing in scope. And you can see, we added a few fields. We needed to go beyond just doing these HTTP requests and checking things that way. And we wanted to look into what's going on in the database here and there. And so that's where we added in some query fields. And so you can see it's increasing in scope, but we wanted to template things out and make it easier for us to continue to work with. And so that's where we ended up defining these two different test case structs. One more so for our SQL queries, the other more so for our HTTP tests. And we each have a test case embedded there with that metadata that was relevant to us, as well as some interfaces so that we could reuse these for all of our test case needs. And so, right, it's expanded and we've templated out so it's easier to work with, easier to build with. And then we get to this point. We have a test client that they all use, so we're preventing long-lived connections, so some safeguards for us. And we're running this slice of test cases. You can see it's idiomatic, easy to read, and there's 4 of them here, much less lines of code, and easier to just see quick glance, you know what's going on. So this was really easy to continue building off of for our integration test cases. And, it wasn't even that much code to define this custom package for our integration test case needs. But, we've kind of used some of these learnings and tools in other projects, and we came across these other packages that are a part of the Awesome Go repo. So we have API test and HTTP expect here. They kind of get at the same goals, right? Enabling a better way of working with tests that might involve some HTTP requests. So some of the similar goals we had, right? So I think moving forward, we learned from this natural expansion of our test cases and we kind of defined our own project package, right? Not too bad, but I don't know if we would necessarily do that a second time around. So slower learnings here and a natural evolution for our test case package. And I saved the best for last, the test report. For our test report, right, we had to use a package here. So we did a go install for Go test report. It's a package out there you can use to parse Go test output into a single self-contained HTML file. You can see there's quite a bit of good going on the slide, right? Cross-platform support, good Go report, good license. Looks pretty good. And it checked off a really important box for us. Project requirement for release for our integration tests. And it was really nice because it did leverage the native Go test framework and it just needed that JSON output so it could interpret those results to create this HTML file. You can see a top navigation bar where you see general stats, right? So you see how many test cases we ran, how long they took, how many pass, how many fail. From there, you have a customizable title, which again, I've blocked off a little bit. And below that, you have some test groups. The one I've clicked on is in black. So those are the test cases for this test group. And you have a test group in red, which shows some failure indications. And the nice thing here is you can click on those different test cases and expand it to see the different logs going on for a specific test case. So pretty nice. And it's perfectly expandable, right? Because as we add more test cases to our integration tests, well, then they'll automatically get added here, right? Because it's interpreting that Go test output. So pretty nice tool. And this is where the most interesting and weirdest learnings that we experienced occurred. And some of the backstory here, right? We had some team norms, as we all do, right? When it came to validation for our solution, we had 3 steps. The first was, we ran Go tests to run our integration tests, and we all looked for that okay. 2 characters, okay. But thinking about the scope here, right? We're doing integration tests. So you're spinning up a bunch of Docker resources. Now, what do you get when you're spinning up a bunch of Docker resources? Logs, and lots of them. So it was really hard to find those 2 characters among many logs. So we ended up adding a wrapper around that exit code to make it easier for us to visually see that our tests passed. Next, we looked at our test report, right? We looked for the green checkmark indications, and we were good to go. From there, that third step was to get with that validation engineer, get him to sign off. And then we were good to merge to main. So 3 steps. All right, so I have added that negative test case. We talked about checking that our camera feed stops and checking how our solution works with it. So I've added this test case, ran go test, all my services spun up, but this RTSP negative test case, right, where we're stopping the camera feed was unique in the fact that we were starting and stopping services mid-test. But, everything looks good. Everything passed. You all see pass, pass, pass. So check. And you see that wrapper that we added for the exit code where it's visually representative that it passed. So I checked my test report. Step 2. So I'm running go test, piping that test to JSON because I need that JSON to then give to go test report because it needs JSON. So you can see we have our test cases here for the stopping of that RTSP server. You see clean and green. Looks good. So I've made this change. I've done my checks and I have that PR out there. And I asked my team, hey, can you check it out? So Anthony on my team, he checked it out. He ran go test. Looks good. He checked my test report. Looked good. So I thought I was good. So continued on and asked that validation engineer to check it out too. Well, test pass. Still doing pretty good. And then he checks the test report. And do y'all see green on this test report for the validation engineer? No, I didn't think so. I don't see it either. So it was really strange, right? So if we look at what's going on here, this is our HTML test report from Go Test Report. We see a bunch of red X's visually indicating failure. And, if we look at the logs for this first test, we see 1 log, which is a little suspicious, right? We should see a few more. So we kind of look at some of the other test cases, right? So this is one of the test cases. We're looking at the logs going on here. I see pass. Do y'all see pass in the logs there? All right, I see a lot of nodding heads because I see it too. And it's not just because I'm wearing contacts, it's there. So we didn't really know what to do. What do you do when you get conflicting results? Show of hands, how many of you have had a weird issue like this? Way more than I expect, which that's cool, but also not cool, right? Because it's really hard to debug, especially when it's the case that it works for some, but not all. So we knew we for sure didn't want this merged to main. No one would want that. And it was failing inconsistently, right? It worked for me, worked for Anthony, but did not work for that validation engineer. So we couldn't prove that our tests passed because we needed that test report output to give to our stakeholders. So that was a bummer. And at this point, we didn't really know if it was different hardware, different versioning, maybe of Go, maybe an operating system, maybe Docker Compose. So we needed to look further because we needed to find a solution. And if we kind of zoom out a little bit, this is kind of what's going on, right? We have this negative test case, which we're starting and stopping some services throughout the test case. So we have our containers going. They're generating container logs all throughout this test, which are getting combined with the test case logs themselves. So all of these logs were getting combined and interleaved. And so we kind of boiled it down to, okay, well, maybe it's all of these logs getting combined because that's what's getting passed to our Go Test Report package, and that's what it's interpreting. So we looked a bit further. Well, I put some glasses on just like this gopher did, but I'm wearing contacts today, so I won't be super traumatic for you all and put actual glasses on. But if you look here, let's take a peek. This is the logs that I experienced. So this is output from test to JSON, right? So I've ran go test, piped this to test to JSON. And this is what we're seeing. You see, okay, we have a test case. We're starting that RTSP server. and you see pass. Pretty straightforward, right? But this is what the validation engineer was seeing. And so keep those glasses on. He had a test case, right? It's the same test case. All right, looks good. We have the starting of that RTSP server. Looks pretty good. It passed. So does anyone see a difference here? Yep. Yeah, we have a few, and I heard it. And so here's where you can see it. So the logs were different. And, you know, my log said starting RTSP server, and they ended with a new line. And our validation engineers had that /R. And I didn't even spot this. Anthony was the one who had his glasses on, and he said, hey, there's some extra characters here. So the validation engineer's log started with those /Rs. And it also ended with an additional /R. Strange. And something else to note here is we had that /N. There's not one for the validation engineer. Furthermore, we had this action, right? So test to JSON gave us this passing action from our Go test results. And you see it's a pass for this test case. But our validation engineer was missing that. Strange. And so, I want to point out too, I couldn't get this to occur on my machine, right? Anthony couldn't get it to occur on his machine either. So how hard is it to debug an issue that you can't reproduce? Pretty hard. And so, I mentioned that validation engineer was missing the /N, right? He didn't have that new line character at the end of that log. And so that's kind of why we're seeing all of these passing indications on one line here. So this is one test case. How many passing indications do you see in the logs? Show of fingers, I guess. Yeah, that's good. I kind of made it obvious. It's 3. So one test case showing 3 passing indications. Strange. And part of that's because of those missing new lines. And so it was kind of weird, right? This is very strange. And so we kind of looked at the greater Go community because we clearly cannot be the only ones experiencing a strange issue like this. And that's where we came to one of our first interesting finds. We found this issue on the Go repo. It's from 2018. It's still an open issue. So it reads, testing, standard output with no new line produces confusing, corrupt -v output. I didn't mention until now, we were actually using that -v flag. So when it comes to integration tests, right, they take a bit longer to run. And so right from the get-go, we wanted to have those extra logs so we didn't have to rerun our test cases and take extra time. So we also had that -v flag, and we were also missing that new line for our validation engineer. So sounds familiar, right? We're experiencing the same issue. This person further commented, we have some tools that parse test output, which get confused in this situation. We had a pretty confusing Go test report for that validation engineer, so it makes sense. Next, we had another interesting find. So we were using that test to JSON tool to give us that JSON output. And there's an issue on the Go repo again from last year. It reads, test to JSON does not recognize test status if output did not end with new line. Y'all saw, we didn't have a new line for that validation engineer. And so this is another case where it makes sense that passing action that I saw in my logs, the validation engineer didn't see. So the test status wasn't getting interpreted right. And so, at this point, we tried thinking, well, are there other ways that we can get that JSON output? Y'all can think of other ways, right? There's the JSON flag for Go test. And so we looked at that as well. And so, if we continue along in some of these comments on some of these issues, there's this other really, really interesting one. And the last comment, the last sentence is of particular interest. So it reads, the testing package writes structured line-based output to standard out, and tests can write stuff there too that interferes. So that makes sense because we had additional characters and we had some missing new lines. And I mentioned we tried the JSON flag, right? And so we kind of looked if there were issues with this approach as well. And I came across the issue for the Go repo where they have this proposal to add that JSON flag to Go test. And they had a lot of discussion naturally on this subject. So Go test framework, they didn't want to format the output in add characters and change it because they knew that there were third-party consumers interpreting those results. So this comment from 2013 shows that there are third-party Go test enhancements that change that output format. Add characters, remove characters. So that next line, right here, it shows that the assert package adds \r's if you have t.errorfs. And they further touch on how this would break that parser. Well, that sounds familiar, right? We have a parser and it's breaking for our validation engineer. So we had that Go test JSON. We had additional \r's, some missing characters, right? That missing new line. And we had an incorrect Go test report for that validation engineer. So to kind of recap the things that we tried, right? Initially, we were using that test2JSON tool and we were experiencing issues. So we tried switching to using the JSON flag, also experienced issues. And so the thing that did the trick for us was looking at, okay, we have these additional characters that we don't want. Where are they coming from? TestContainers-go, whenever we were running this negative test case and starting and stopping services mid-test, was adding some of these additional characters we didn't want. So we ended up removing this, right? So we removed TestContainers-go to remove those additional characters from being added to our test output. And that did the trick. Our validation engineer was able to see what I saw right from the get-go. Mic drop, right? Success. Do y'all see red there? Nah, we're good. So that did the trick. So you all saw it was quite a journey. Lots of learnings, lots of weird things, which makes it fun along the way. And to kind of wrap up what we've covered here, because I know we touched on a lot. We had 3 things going on here. We had TestContainers-go, managing our test dependencies, and it was maintainable and it was scalable, right? And it enabled us to test what we were deploying by using that Docker Compose approach, but it wasn't perfect. Y'all saw. We also had a custom package for our test cases. A little more code, but it just naturally evolved and progressed for our solution, and it worked for us, got the job done. And from there, we had that Go test report. It was user-friendly, pretty, scalable, right? As you add test cases, they get added to this report, and it fulfilled an important piece, a project requirement. So a good V1, perfectly automatable, right? Because you can do a Docker and Docker setup with your CI. And y'all saw, not perfect, so quite the journey. And I do want to point out that risks can pay off. So this whole Go integration testing journey started with us and it's propagated from there. So our org is shifting away from that Python robot framework approach and kind of reusing some of our packages here. We also have an internal release tooling team looking to support Go in future iterations to better enable us Go developers for our solutions, but also better enable a strong test phase for that software development lifecycle, SDLC. So we're always improving. Hopefully at this point, you've gotten some useful insights into some Go integration test packages, and you've seen our mistakes and learned from them just like we did. And also, I hope that we're all mindful, right? When we're producing output, that others are interpreting. Well, be mindful of things getting thrown in the mix that are unexpected. And also, be feelers with your journey, right? Because we were fearless and I think it paid off. So if you want to know more, I did present at the Open Source Summit with a co-worker of mine. So you can access that talk here on the other components of our Smart City solution. The slides for this talk, as well as that talk, will get uploaded to this repo, as well as my website after this conference, right? So I could take a breather. And then, if PowerPoints or YouTube videos aren't your jam, well, there is a paper in the September edition for the IEEE Smart City section on this solution as well. So definitely check it out. And thank you all so much